All right, good morning. I want to apologize for any of you that were here earlier and I wasn't there. I was having Blackboard difficulties. It took me having to try and get IT on the phone, but luckily it's been fixed. So with any luck, there shouldn't be any more glitches along the way, but you know, bear with us as we figure out all this online learning. I did look at your discussion board and there was a comment in there about wanting some more hints towards piecewise. So I wanted to go ahead and give you another mini instruction about piecewise functions that you can refer to as you need to. Okay. So first and foremost, when we're talking about piecewise functions, remember we're going to have a function, and this function is going to be made up of multiples, so at least 3, if not more. So let's look at x plus 1, where we know that x is less than negative 2. And then let's look at 5 for negative 2 less than or equal to x less than or equal to 3. And then let's do x squared for all x greater than 3. Okay. So what you need to remember is that these parts here are the equations, and then these other parts, so this part here, these are what are called bounds. Okay, so we've got equations and we've got bounds. So when we're talking about bounds, okay, your bounds are going to kind of be like your start and stop values. Okay, so bounds are going to be where to start the function and where to stop the function. Okay. So when we're talking about bounds, we are talking about that specific idea, where to start, where to stop. Okay. So in order to graph, says that we have to look at each one of these as their own individual piece. So if you think about it, in order to do this, we have 3 problems. This is problem A, this is problem B, and this is problem C. And we have to look at them all individually and on their own. So when we're doing that, the easiest thing to do is to start by making yourself an XY table. Okay? So first and foremost, let's start with problem A. And when we're working with problem A here, we're looking specifically at creating or choosing x values specifically rated for the function f of x equals x plus 1. Okay, this is the only thing that we are looking at the moment. So when we are choosing your x values, you have to, or you must, choose the bounds. So we're not just choosing any value at all, we are specifically choosing your bounded values. Okay? So in this first one, if you look, we are talking about any values that are less than negative 2. So for this first one, this means I have a bound at negative 2. Okay, that's what we're saying. So I have to start there. I have to use the negative 2. Regardless of what your inequality says, you must use your bounds in order to graph. Now, the inequality piece tells you if the bound is included or not. Okay, so here my bound is at -2, but then my inequality just says less than. Therefore, -2 is not included. So here my bound at -2 is going to be open, meaning it's not included. Okay. So when we're talking about open, what I like to do personally is I like to put a tiny little open circle kind of right next to my bound, which is reminding me what my bound value was. Okay. Now we have to plug that in. So if x was -2, we have to know where y is. So -2 plus 1 is a -1, and therefore that's my first point. Now, because this is linear, remember linear requires two values in order to graph. So I need to choose a value now that falls within the bound. Okay, so if you only have one bound, then to find your second or any other point says you have to choose a value that falls within this bound value. So I have that x can be any value less than -2. So on my number line, it means what I'm doing here, if you look at, say, this number line, remember back to your inequalities. Here we've got -2. Remember, this was the positive side, this is the negative side. Input your 0. And what I'm doing is, because this is just less than, remember you've got your parenthesis, which means not included, and we have to shade in this direction. So when I'm trying to choose another point to use, I need to make sure I choose a value that falls in my shaded region. So for example, I would go ahead and choose -3. So here, -3 plus 1 is going to give me a -2, and thus I have my 2 points. So this is only that first part. Okay. Now the second part, we have 5, and then we have these bounds. So now we're going to look at part B, because notice I have not graphed yet. And part B says I'm going to choose x when f of x is 5. Again, in order to do this, says you have to choose the bounds. Okay. So in this case, if we go up and if we look, notice my bounds here are -2 to 3. I've got 2 of them. So if you have 2 values that are surrounding your x, those are the 2 that you need. So I have to use -2 and -3. So if we're looking at it for my second one, I have a bound at -2. And I have a bound at 3. Again, if you were to take a look at your inequality graph, look at the information you have, and I have -2, remember input your 0, and then 3. And then if you look, your inequality here had less or greater than or equal to and less than or equal to. So in your number lines, if you remember from inequalities, that meant brackets that went around them, and we would shade everything here. Okay? So that means if we're talking about these bounds, because they both have equals to, it means both of these would be closed. Closed meaning included. So I have to use my 2 bounds. So -2 and 3. And both of them, I would put a solid circle next to them because they're both included. Okay. So now you're going to go ahead and you would quote plug it in, but remember this is going to be that special case because when we plug -2 in, you still spit out a 5, and if you plug a 3 in, you still spit out a 5. Okay, so this is that horizontal line, but this is essentially what you have to do. Now, last but not least, we have our third. So we have case C. And here we're looking at x, and we're looking at for all f of x equals x squared. And so again, you need to choose the bounds. And so if we come back and look, we look at our third one here being x greater than 3. So here, I have a bound at 3. Based on my inequality, it is open. Okay. So again, remember, if you looked at its number line, just for clarity, here's your negative side, here's your positive side, input your 0. So we had a 3. My 3 was open, so it was a parenthesis. And my inequality said x is greater than 3, so we are shading now in this direction. So the first thing I have to do is I have to choose my bound. So I'm starting at 3. And my 3 was open, so I'm going to put a little open circle next to it, which reminds me. So now I have to plug it in. So this becomes 3 squared, which is 9. And now I need to choose at least one or so more points that are in this positive part. So I would go ahead and look at 4. So here we'd have 4 squared, which is 16. Now we know it's quadratic, okay? So we know that we would graph it. So let's take a look at the graph. So here for me, let me just draw it in for you real quickly. Okay. So I've got my straight line here. Got my straight line here. It's pretty, close enough. Okay. So I have to look at the points that I'm using. So first and foremost, I have my first set. Okay. So these are the values that I'm using, and I need to pay attention to my open circle. So I have the point -2, 1, and then I have the point -3, -2, and I got to use my open circle. So first and foremost, we're going to go -1, 2, and then we're going to go down 1. And so this would be that first point, and it's an open circle. So I would draw it as an open circle. And then we have the point -3. So here's -3, -2. And so this would be this point here. And it's included, so we would make it closed. And then that's all we needed. So then you would come in, and we would go ahead and draw, say, that line, which would start here and go down in this direction. And this is going to be the line that is x plus 1. Okay. And specifically with this line, we are looking at x being less than -2. So that's kind of what we're doing with that one. Then we have our next piece, which is going to go from -2 to 3. And my y values are up here at 5. Okay. And they're both closed circles. So I've got -2, and I need to go up. So we've got 1, 2, 3, 4, 5. So at -2, I'm up here at 5. And it's a closed circle, so I'm going to go ahead and darken it in. And then I'm going to go all the way over to 3. So I've got 1, 2, 3. And 3 is going to come up here to 5. And again, it's going to be a closed circle. And here you're going to go ahead and just simply connect your dots. Okay, so here we go. They're going to come straight here. And this was going to be the graph that f of x equaled 5. And for your bounds, -2 less than or equal to x less than or equal to 3. So that's what that line was. The last one we have is this x squared piece. Okay. So here at 3, we're up at 9. So this was 5, 6, 7, 8, 9. So at 3, we're up at 9, and it's an open circle. And of course, over here at 4, we went all the way up to 16. So here, this graph, because it is a parabola, is going to have a slight curve to it, and it's going to kind of go up in that direction. So here, this is the part that f of x equals x squared, and it's for all values greater than 3. Okay? So that is how you graph your piecewise functions using the bounds that you have been given. Okay? So, as always, the next time we meet, remember, if you have questions, to put them in the discussion board. Again, I do apologize for the technical difficulties this morning. So please make sure that if you are confused, you either email me, write it down in the discussion board, and then we will meet again as a class on Thursday at Thursday at noon, just like your normal class time. Okay? So I hope you all are doing all right, and we'll see you next time.